Now we've completed our parent function worksheet. Let's go over these and look at our answers for what these different graphs and functions look like. First off, the constant function, f of x equals 2. Now, this is just a horizontal line at 2. So my domain, my x can be anything, is negative infinity to infinity, all real numbers. Now my range is just 2. It's a horizontal line. That's the only thing you get out of it is 2. The identity function, f of x equals x. This is a line with a slope of 1 through the origin as my y-intercept. So this is just a kind of a diagonal right at 45. My domain is all real numbers, and my range is all real numbers. And really, any line is just a take off of that graph. So there are next two. Absolute value function. When you see absolute value, you always want to think V-shaped. Looks like the identity to the right with a slope of 1. V's the other way. Everything's positive. Also a slope of 1. Try to do my best on the graphs here. My domain is, once again, I can put anything into the absolute value function. Put any number in there, it still works. My range is only positives. So that range is only from 0 to infinity. Square root function. I can't put a negative in there, so my square root function looks like this. A couple key points here. It's going to go through the point 4, 2. It's going to go through the point 1, 1. So my domain is I can only take the square root of positive, so it's from 0 to infinity. And I can take the square root of infinity, I can take the square root of 0. It's 0. And my range is also only positive numbers. The last two on the front. Quadratic, x squared. We know what quadratic looks like. A couple of key points here. If it's just x squared, our vertex is at the point 0, 0. Then it goes through the point 1, 1, 1, negative 1. It goes to the point 2, 4, and negative 2, 4. Obviously, if we kept going, it'd go through 3, 9, and so forth. And then our quadratic looks like that. My domain, once again, all real numbers. No problem so far. Now my range is only the positives. X cubed. There's 3 points here. 1, 1, negative 1, 1, and 1, 0. Looks like this. The domain is, once again, negative infinity to infinity. And my range is the same thing. Our goal at this point is we should pretty much know these 6 graphs and the basic shape without having to need a calculator. We should be able to graph those without a calculator. We should understand those graphs, those functions. Now, as we go to the back, these get a little bit harder. We're not as comfortable with these. First off, 1 over x. The graph of 1 over x goes through this point 1, 1 here, and it kind of comes down, curves like this, and goes to the point negative 1, negative 1. This kind of comes down like that. So you can see, we haven't really talked about this yet, but there's a horizontal asymptote at 0, so it never crosses the x-axis. It also never crosses the y-axis. So my domain goes from negative infinity to 0, but doesn't include 0, and then it also goes from 0 to infinity. It's never equal to 0. And my range is the same thing. You can kind of see why it never equals 0. For a fraction, 1 over x, to equal 0, the top must be 0. The bottom can't be 0 because that's undefined. But if the top has to be 0 to equal 0, and 1 never equals 0, so you cannot put 0 into this function, and it can never equal 0. All right, our next one, the cube root. This is very similar to x cubed. Goes through these same points, but it's been kind of flipped. It's kind of like x cubed on its side. So my domain, all real numbers, and my range, all real numbers. Now we get a little bit harder. E, exponential function, e to the x. This goes through the point 0, 1. It gets close to, but never touches, never crosses the x-axis. And then it curves up. So my domain is all real numbers. If you didn't find it, E is a button on your calculator. If you try to put this into your calculator, it's second ln is our E. Is how we can graph it. Okay. So what is our range? Well, it never gets to the x-axis. So it never equals 0. So our range is just 0 to infinity. Natural log, also on the calculator. This goes through the point 1, 0. Once again, comes up and levels off. This never gets to the y-axis. So my domain is from 0 to infinity. I can't put 0 into natural log. If you tried natural log of 0 on your calculator, you get an error. I can't put negatives into natural log. My range now is positive to negative infinity. It goes down forever, and it continues to go up forever. My last two functions here are sine and cosine. Now, these are really hard to graph at this point to try to get the points in. I'm going to put the points where they need to go. At this point, all you need to do is look at this and say, well, kind of looks a lot like a wave. And if you get that idea that it kind of looks like a wave like this, that's the key. If we do the wave here, something like that. Now, the domain for both of these is the same. Negative infinity to infinity. The range, you can see both of these waves where the peaks and valleys are. The range is negative 1 to 1. They only go up to 1, and they only go down to 1. They just stay this wave motion between those two. So, these are our parent functions. As I said, the ones in the back, sine, cosine, natural log, e to the x, the cube root of x, 1 over x. Those are a little bit harder. Those are probably new. We don't use those as much because we're not familiar with them yet. Eventually, by the end of this class, we'll be familiar with all of these the same. So I'm not too worried about the last 9, 10, 11, 12. We know them. We'll use them a little bit here, but those are probably pretty new for you. The ones on the front should not be brand new. Those should be familiar. You should know those. You should understand how to graph those. Because as I said at the beginning, our goal is going to be able to graph all of these from memory. Without a calculator, without having to go through and do a table of values and plug points in and graph the points. We just have to know how to graph them and just write the graph down. Now, we will use these a lot more. We will practice these more before we ever get to a quiz, but that's kind of where we're headed. That's where we're going with our parent function.